Fuel enters the fuel pressure regulator housing from the OEM-supplied fuel tanks at the top of the fuel pressure regulator housing through the fuel inlet fitting and flows into the low pressure regulator. Fuel flows to the fuel regulator intake pressure sensor. The minimum fuel intake pressure is 60 psi, 414 kPa, and the maximum fuel intake pressure is 150 psi, 1034 kPa. Fuel enters the low pressure regulator where the fuel is regulated for normal operation to 55 to 101.5 psi, 379.2 to 699.8 kPa. An air line from the air intake connection in front of the engine intake throttle actuator provides the boost pressure air to the low pressure regulator. During conditions in which the engine is under heavy load or increased boost pressure, the boost reference line will assist the spring in maintaining the flow of CNG through the low pressure regulator. Fuel from the low pressure regulator then enters the fuel shutoff valve. This valve is a normally closed valve that opens when commanded by the ECM. Fuel exits the fuel pressure regulator housing and travels up to the fuel control housing. Here it passes through a laminar flow screen and flows past the fuel regulator outlet pressure temperature sensor. The output of this sensor, combined with other sensor outputs, is used by the ECM to calculate the air-fuel ratio. After the fuel flows past the fuel regulator outlet pressure temperature sensor, it travels through the venturi to the gas mass flow sensor. The venturi forces approximately 10% of the fuel to flow past the gas mass flow sensor wires. The gas mass flow sensor calculates the amount of fuel flowing to the engine by measuring the cooling effect of the fuel flow across two electrically heated wires. The sensor then sends a signal to the ECM proportional to the amount of gas flowing past it. The ECM uses this signal to make adjustments to fuel flow into the engine. Fuel flowing past the gas mass flow sensor wires rejoins the remainder of the fuel flow. The sensor is a hot wire anemometer that measures the amount of power required to keep an electrically heated wire at a constant temperature. As more fuel flows over the wire, more power is required to maintain the constant temperature. Fuel then enters the fuel control valve. This valve is a normally closed valve that opens when provided with a pulse width modulated signal from the ECM. Fuel flows into the front horizontal vane of the mixer, where it is mixed with the intake boost air that has entered from the engine intake throttle actuator. The fuel air mixture then mixes with the EGR gases that have entered the rear vertical vane in the mixer from the EGR control valve. The system is designed to only allow approximately 30% of the EGR gas flow into the mixture. After leaving the mixer, the fuel, boost air, and EGR mixture is then routed through the intake manifold and onto the intake valve for each cylinder. Before the air-fuel EGR mixture enters the intake manifold, the temperature and pressure are measured by the intake manifold pressure temperature sensor.